A lot of time people do non-experimental research or correlational research, and they claim a cause and effect relationship. So as a researcher, you gotta know that we need to have all those four elements to be able to make conclusion about cause and effect relationship. What does it mean? For example, probably you have heard of claims like there is a high correlation between the number of smiles that you make per day and your lifespan. Or people who eat fish a lot, they have a longer life. This kind of research is not experimental. What does it mean? It means that if you increase the number of smiles you make, it doesn't necessarily increase your lifespan. It's just happened that a third variable is involved. So probably people who are happier probably are richer or healthier. They tend to smile more, and as a result of their condition, they're going to have a longer lifespan. The same with eating fish. Probably those who eat fish a lot live in specific countries, in specific regions, specific environment that makes their life longer. But it doesn't mean that if you start eating fish today, we're going to live longer as a result. These are not experimental research, and there's always a third variable that can explain the relationship between these variables. A similar wrong conclusion is when you have a directionality problem. For example, probably most of you have heard there is a high correlation between how much you watch violence on TV and how much you show aggressive behavior in real life. And many people just assume that it's the TV or watching violence on TV that makes you an aggressive person. But a more legitimate argument could be that probably people who behave aggressively in school, they just are type of people who prefer action movies or violent movies. They don't watch other things. So it doesn't mean that if they stop watching violence, they're gonna stop behaving aggressively. Or it doesn't mean that if people who are not violent, we force them to watch violence on TV, they're going to start aggressive behavior. So the point is that if you just compare groups, or if you just calculate correlation, it doesn't mean a cause and effect. For a cause and effect, we need the most important element of experimental research, which is manipulation. So we need to have two groups. One group is controlled, the other group is treated in a specific way, and if there is any difference between these two groups, then we can say, okay, there is a cause and effect relationship. Sometimes manipulation is easy. For example, if we want to see that there is a relationship between temperature and ice cream consumption, we can simply go to a dorm and increase the heat in the building and then have like free ice cream in the basement and see how many ice creams are consumed as you increase the temperature. However, sometimes it's not easy to manipulate the variable like increasing the heat in a dorm. For example, if you want to see the relationship between depression and insomnia, you cannot increase people's depression to see how it affects their sleeping. So one of the things that you need to know when you're doing experimental research is that sometimes there are some confounding variables that we're not aware of. Okay, so for example, in your textbook there is a very interesting study that a researcher wants to see if he uses humorous words in a memory test versus non-humorous words. Does it affect students' memory score? So the first time he does it, he observes a significant difference between the two groups, and the humorous words are much better in terms of students' memory score. However, he thinks more thoroughly into his research, and then he says maybe it's not the humor that makes the difference, it's because they didn't expect humor. So it's a surprise factor that's working, the novelty factor that's working. So what do you do in this situation? Simply, you have to remove the confounding variable. So the way this researcher did is that he actually controlled the level of surprise by telling them what kind of words you're going to get. Is it going to be humorous, or it's going to be just a normal word? So this way you can remove the confounding variable, in this case the surprise factor, and then do a better study, because this time any difference that you observe is due to the humor factor, not the surprise factor.